Alright, welcome back everybody. Another episode of Crazy Dad's Garage, working on the Crazy Dad Rat Rod. We have it up in the air today because we are going to tackle redoing the steering on it. I've got a rack and pinion unit that I'm going to put in it, and I've had this other steering box and a drag link there and a tie rod that wasn't working out. The tie rod was my biggest issue, and then the steering ratio wasn't working out right either. But tie rod doesn't have room to move up and down. It's going to hit that radiator when we're driving, and so I'm going to pull it out of there. I'm going to mount that rack and pinion in there where the tie rod is, and then I just got to hook up the steering linkage to it. And I've got a rack and pinion unit out of a 2006 Chevy Cobalt. It's a manual unit instead of a power steering, which is what I was really after. And what I'm loving is it's like it was made for this thing. It requires about a little over 4 inches of height, and I've got 4.5 in here. And the steering shaft on it, here it comes out a little bit of an angle, and it's actually going to fall right in here, which is going to work out perfectly. I'll be able to shoot it out through here and route my steering shaft up and through here to hook up to my steering column in my access hole, which I have to fix, but that comes after I do all this stuff. So anyway, that's the project for today. So my first thing is I'm going to get the tie rod out of there. I'm going to get this drag link off and unbolt this steering arm that I've made here. I will get the steering box out of there, probably go in and pull my jointed shaft out of there. So I get all that stuff cleared out of the way. I got to take my bracket off here. Fortunately, I made it so it bolted on. I think I could just unbolt that. And then I'm going to have to move this steering line a little bit, but it's going to work out good. At the worst case scenario, I may have to get like a 45 or something and run down here because it's going to clear that fan blade, and that's my big concern right there, but I think we'll be all right. So that's what we're going to be doing on this project. So I'm going to dive into that, and I will show you the pile of parts after we get everything torn out of there. There we go. Took about an hour to get all of that out of there. Look at the massive amount of fabrication work that represents. That's crazy. There's hours and hours in there, but hey, that's what it is. I'm really glad that I took it out, because here's a side-by-side comparison of what we're going to end up with. Even the weight savings is going to be probably half of what the other thing was. And yeah, I'm going to have to come up with one more jointed shaft, I think, to put this one here in, and a bearing maybe, but it's going to be so much simpler, and it's going to completely solve my problem, so I won't have anything in there hitting the bottom of my radiator now. Let's see. I can't get a very good picture, but that round tube cross member is what it's got to sit on, and actually that bracket right there is really what it has to clear. So that's where we're going to be next, is trying to get it all stuck in there. So we'll work on that. I've got myself a center line drawn on the rack and pinion and on the frame, and I need to just see if I can get it in there. That's my first big challenge. So we'll move to that point, show you what it looks like there. Alright, so you can see now we've got that rack and pinion unit in there, and it fits just barely, which is really awesome. It's like it was made for this place. So we had, we trimmed up this piece here so that I could get the U-joint on it, and I had to take the radiator out. It had to come out anyway, but it would have had to come out to get that unit in there because I had to take both of these braces loose on both sides and move it a little bit. So we did that. It's sitting over there doing some repairs on the radiator. And then I came in here, built myself some brackets. That's the front part of the bracket right now, and I've got them in there and welded to the cross member. Yeah, right up to there. So I'm going to put those there. Now I'm going to go make myself a second bracket that's going to go on the inside here. So I'll have one on each end of this bolt, so the bolt will be thoroughly held in place with the two brackets, and that's going to be more than enough to give me the strength that I need to get that thing in there. So it's working. We just barely clear our fan by about a ½ inch, which is plenty. So we should be in good shape. So there's where we go. I'll come back here and show you when I get that second set of brackets welded on the back side of there. There we go. Okay, we've got that second bracket, or set of brackets put in down there. Right there. Got that welded on, so that now we've got it pinched between the two brackets, so that means it can't go anywhere, and that should have us plenty strong. And I've got the tie rod ends pulled off of the tie rod, so I can start figuring out how I get from there to there, because I'm going to need my Ford pickup tie rod ends out here, but I've got to leave adjustment in it and still attach them to this. So I'm working on that. I'll do a little more figuring and I'll show you what I've come up with. Alright, here we go. This is my solution that I've come up with after a lot of measuring and mocking things up. So I've cut the end off of the tie rod coming out of the rack and pinion there. By the way, don't do this at home. You got to be a good welder and know what you're doing to do this. And I'm going to just show you what I did. It's not a recipe for you to follow. I'm just showing you how I solved a problem. So what I did was I cut the end off the tie rod that fit on here, and then I reamed the threads out of it so that it will slide over here like this and hold itself in place. Now what I'm going to do with that, I'm going to not only run a bead around the end of it here, but I've got these ½ inch holes drilled in it there so that I can plug weld it too. And that will allow me to get plenty of strength there to be able to put that together. And then I took my tie rod end for the truck that actually fits the spindles that I've got, and I ended up, I think you can see, I ended up cutting a ½ inch of length off of it in there, because that's going to give me all the adjustment that I need for this project. And I've cut this one out for a plug weld too, so this isn't going to show up or hold itself up here so I can do this. I'm going to put the camera down, put it together. There we go. So I'll slide that over that other sleeve that I put in there to bush it out after I grind it down and trim it up, and that will give me the overall length and everything that I need here to be able to make this work. So again, yeah, I'm doing this. I'm the one who's going to be using it. I'm confident in my welding ability. This is not a recipe for something you should do at home. This just shows how I solved the problem. But anyway, that's what I'm going to do. I'll do that on both sides, and that should have me plenty of strength and adjustability and allow my rack and pinion to work. So that's where I'm going. I'm going to get those all welded up, then I'll be back and show you the finished result with that and move on to the next part. So here we go. We've got that part finished. I got my tie rods all taken care of and welded up. And for those of you that aren't aware, just make sure this one weld right here is not good enough. That's why I've got those plug welds through here and through here. So combine those two welds there with a nice bead around there, and we should be plenty strong for what we're doing. So this allows me to adjust the toe by simply loosening this clamp and turning right there with a wrench. That'll let me adjust the toe in. So it's fit just beautifully. I had to do a couple of simple little things. So this bracket right here, I had to move it up about 3/4 of an inch because my hose was hitting the boot there as it went in and out and causing problems. I didn't want that there, so move that up, solve that problem. And then I was having a clearance problem between here and the brake line. So I relieved this on the spindle. These are huge spindles meant for a 1/2 ton, 3/4 ton truck, and so there's tons of meat in there, so I'm not worried about that. Got that out. Now I'm clearing here, and I think we're going to be in good shape. So that's got me all set up all the way across both sides. Yeah, I'm sure you can't see that very well, but that's set up. Now I'm going to move on to the steering shaft. So I've got this one here. I'm going to need at least one more U-joint probably to get from the bottom of my steering shaft in the cab down through the floor and over across here to that shaft. But I'm liking the way it's coming together, looking really slick. I'm going to see if I can find myself another shaft here and put those two together, and I'll have to build a bearing of some kind, but we should be in good shape. So that's the next part of the project, getting this rack and pinion in. And so far it is steering beautifully. I know I don't have it on the ground, but it's actually turning easier than the other one did up in the air too. So I think we'll be in good shape. We will see how it comes out as I get this steering shaft figured out. I'm going to take just a minute here and explain why I could get by with using a rack and pinion unit on this setup. Because a rack and pinion is really designed to have a twin A-arm front suspension, so you've got A-arms moving up and down each side, and in theory the A-arms pivot right where at the same point where the tie rod pivots in the rack and pinion, and that allows them all to stay in the same range of geometry together so that the steering angles don't change. And when you tie a rack and pinion to a straight axle, solid axle like this, as the axle moves up and down, it causes that tie rod to move up and down, which effectively changes the length of it, because that end of that tie rod is moving in a half moon like this, an arc. And so at that point, we can set the toe right there, or set the angles right there. But then as we hit a bump and that spring compresses, that tie rod is going to move up, which is going to mean that it's going to be effectively a little bit longer, so it's going to push the back of the tire out, which means as you hit a bump, you're going to get your angles changing on your steering, and that's why you get something called bump steer. So the reason we can get away with that on this setup is because look at the minimal angle that I have that going down right there, and when we hit a bump, there's only going to be 2 or 3 inches of travel in this thing realistically on a normal bump. If we're hitting something really hard, yeah, it could be worse, but what's going to happen is that thing's going to come up straight and maybe a little bit of an angle that way. So the amount that it's going to push the back of the tire out is going to be almost negligible on this thing. So it's not going to change it very much. Then you couple that with the other side is effectively doing the same thing. And so your tires are both going to change at the same time, pretty much. And that should prevent any serious bumps here on this thing. There might be a tiny bit, but I will almost be willing to bet you won't even notice it. And so that's why we can get away with that. I wanted to explain that because you can't always do this. For instance, if the place where my ball joint, my tie rod end mounts to the spindle was actually up here, that would give us a very steep angle on this tie rod right here. And what that would do would cause it that when you hit a bump, it's going to move a lot more and actually cause some serious bumps to your problems. So that's why we can get away with it here. I just wanted to explain that so that if you're building something and you have a question about that, you'll be aware of that and won't have a problem with that yourself. But overall, we've come up with a much, much better steering system here on this thing, and I'm really glad that we went this route. I'm excited to get it down on the ground with the weight on it and see how hard or easy it is to steer. I think it should be very similar to the other one, and I think we're going to have made a really good choice here. Alright, we've made some progress here and gotten these steering shafts kind of settled in. So I'm going to walk you through that. I have had one steering shaft here that came out of the 06 Chevy Cobalt that I got the rack and pinion out of. And that got me back here, but it became obvious I was going to need a second shaft, so I went to the wrecking yard and got a second one out of another Cobalt. And I think you can see it in there, yeah. So I've got it set up in there. And once I got them aligned, then I've cut a piece of 5/8 steel rod to connect the two of them. And I've got it all mocked up here now, all except for the final welding of getting this bar welded to these U-joint ends here. And then I've got to get back up in there and weld it into the steering shaft, the steering column. And so that's kind of where we're at. So a couple things that I've done here. I knew I was going to need a pillow block bearing to, because when you have this many U-joints in something, you've got to have something that stabilizes this thing or the whole steering will flop all over the place. So it's kind of puzzling what to do with that, and being an old carpenter, this idea came to me that I thought was really cool. You can go out and buy a metal pillow block bearing. I don't know what they cost, but it's going to be 20 to 50 bucks to get one. I was going to need 2 setups for that, and didn't want to spend that money. And this, as a carpenter, was appealing to me. I've gone back and toured some places. They're like sawmills and different things like that that were built in the 1800s. And it impressed me that those things had wooden bearings everywhere. So I got to doing some research on them, and come to find out, and this is really difficult for most people to believe and took me a while to figure out, but I've come to understand that it's really a truth, is that wooden bearings in a low speed, low heat situation are even a better bearing than a metal bearing. And that was interesting to me because the wood can retain the grease and the oil that you put in there, and it just literally never wears out. And that oil soaks back up in the pores and can stay there to lubricate the part that's running in it. And this is not a high precision location for one. It does need to be close and be tight, but you can see I've got this. There's no play in it, but it does spin very freely, and so that's going to work out really good here. I did put this plate on there to reinforce things to prevent any splitting that might happen over time. And I've got the thing coated with oil and greased in the place that the shaft's running in and everything. So it just made something that I was able to make here. It didn't cost me any money. According to all the research I can find, it's a very viable option for this sort of a thing. And so it was just kind of a fun personal addition that I could put on this street rod of mine and make it happen. I needed a second one up here, and so I had a plate that I had cut and put in place to fill this hole where the brake and clutch pedals used to go through the floor. So I made a second bearing there. I ripped that plate out and cut a piece of, I think it's almost 1 inch thick oak to go in there, which is what I used on both of these bearings, was oak. You need to use a pretty hard wood for them. So I cut myself a second one there that will keep that steering shaft from wobbling around as it comes through the floor there, and we'll locate it good and solid. So we got 2 of those in and locked in place to where they will take care of what we need to do there. So that's where we're at now. My next thing, as I've told you, is to be able to get these things welded together. Then I've got what I'm going to do here. First of all, I've got to make sure that this U-joint is perfectly in line with that one so that we keep our phase correct there. It's just like a drive shaft on your rear axle. If you get this and that one out of alignment with each other, there's a possibility of some binding that could happen in it, and I don't want to mess with that. So as I get these together, both of those U-joint ends were splined in there, and I don't have the resources to cut splines in this shaft, so I didn't want to mess with that. So what I'm going to do, these are just a forged steel end on this thing here, so I can weld it real easily around here, which is what I'm going to do. But that's not good enough for a steering shaft, something you got to have a safety feature in. So in both of these, I've drilled myself a big hole, and I'm going to plug weld that in there. And between that and a good weld around here and this bolt, which is clamping them in place to start with, which I'll cut off here when I'm done, doing that will assure me that this joint cannot come apart. You know, even if this weld out here failed, this plug weld in here will keep the thing from pulling out. And so, yeah, it's just going to be like a triple safety thing that will tie all this together. So that should be really effective there. And then I've got to go up, and I've got some more plug weld holes up there. I don't think you can see them from here. No, they're up there. Anyway, I will get everything aligned and then weld the steering shaft to the steering column. So I will get those taken care of, and then I'll show you what I've got going on here once we're at that stage. So that's my next shot here. I'll let you know as we've got that done. Alright, we got her done. This is a big step in the progress of my project here. So we've got all the welding done. I've welded around that edge like I described, and plug welded it there, and then smoothed all those welds up. Same thing back up here at this one. Got that all done. You see I'm turning this by hand, so that's how well those pillow blocks are working. We've got plenty of looseness in there. And then up in there we've got those welds made, welding it up to the steering column. Got everything ground off and back to functional status again. So there we go. Those are all adapters that I had to make to go from the original column, which is up in here, to my jointed shafts going down on the new column. So here we go. We can steer the thing really well now. And one finger working it in the air. Obviously it's going to be worse, but we're about 3.5 turns lock to lock, which it was like 6.5 before. And so that'll have it sitting down there. Now this will be the real test, and I haven't actually tried this out yet, so we'll be trying it out on video to let it down on the ground and see how it actually will turn under pressure. I'm really curious about this because manual steering car, oh yeah, that is great. So if it's turning that well with no movement, this thing's going to be a piece of cake. I mean, it's not like power steering, obviously, but I was concerned that the steering might be too heavy with just that rack and pinion unit, but that's working perfectly. So there you go. That's got us now with a really good steering setup, whereas before I had a really questionable one and just did not like the way that it was going to be working out, but this is going to be awesome. So I've got my toe in set just with a tape measure at about a 1/16 of an inch toe in. I'll do some more adjustment on that after I get the thing on the road, but that will get it to where it's drivable and I can just kind of see what I need to do. If my steering wheel's not centered as we're driving down the road, then I can use the tie rod ends. If I crank this one this way and that one that way, that'll allow the steering wheel to move one direction. Or if I need to go the other direction, I can correct it back the other way. But that'll allow me to get the steering wheel centered, and then we'll be in business and we'll have a drivable, steerable truck here. So that's really a massive step forward in the progress of the Crazy Dad Rat Rod. I've been working on this thing for about 5 years now, and so we're down now to where I can scratch another thing off my list, and I think we are pretty much into the getting. I got a couple of little things to do. Here's my punch list here, but that'll scratch off this one. This is going to be a simple thing for the gauges. I got to do a little bit of work on the gas tank sending unit. Got to take the alternator apart, clean it up, fix it. There's a hole that needs to be repaired. And then it's mostly just monkeying around with getting the engine ready to go. Because I've never put oil in this thing. When I had it torn apart to detail it 20 years ago, I just put it together, and I'm sure I never put oil in it. But I checked it the other day; it still spins over, and so that's going to be in the next series of videos, is doing those things that it's going to take to get that engine moving. So that'll really, truly be a will it start video, and be some instructional stuff there on how to go about taking an engine and getting it started for the first time. So anyway, that's going to be it for today. It's been a fun project here, and that is a giant step forward in our project. So we now have one of the major pieces done, and that's where we're going to wrap it up for today on the Crazy Dad Rat Rod.